So inverse functions, the inverse of f of x, we write that as f to the negative 1 of x. So that notation there indicates that it's the inverse of f. And so I have here several graphs of functions that are inverses, and for each one, I have graphed this line right here through the middle. And that line that you see right there is the line y equals x. Right? It's just a line with a slope of 1, a y-intercept at 0. And graphs of inverses are always reflected over the line y equals x. So the questions I'm going to give you tomorrow on the quiz are going to be some basic inverse problems that you're not going to need the calculator for. But there will be some that we do that are a little bit more difficult, and probably on the test there will be a Desmos section of the test. So one thing you can always do to see if two functions are inverses is you can just graph them and see if they look like they're reflected over that line y equals x. So for example here, this graph right here is a logarithm. This graph right here is an exponential. Those are inverses of each other. Here you would have like x minus 4 versus x plus 4. You can see those would be reflected. I think this was a quadratic right here, the black line. And then this was a square root. Those are inverses of each other. You can see when they're graphed, they're reflected over that line, y equals x. So that's something for us to remember as we do these problems. What it also means is that if a point is on a function, so like if I have, for example, I have the point right here, 5, 1. That means that the inverse of that is going to be on the other function. So if I switch these 1, 5, 1, 5 would be right here. It is on the other function, right? So another example here, right here I have the point negative 2, negative 6. So if I switch those, negative 6, negative 2, that point is on the inverse function, right? So if we just switch our x and y's, it gives us a point that is on the inverse function. That would be true for these over here as well. They just don't hit at grid lines as easily, so I'm not using those to show you those points. So every single point, that's going to be the case for. So that's something that you're going to be asked to do on the worksheet that you're going to have for the assignment today is you're going to be asked to graph the inverse of each function, but this is going to be by hand. So if we have a function that looks like this quadratic right here, and we are asked to graph its inverse, right? We don't have the equation for this. I guess we could probably write the equation if we really wanted to. But for me, it is difficult to picture how to do this. Now, some of you guys, maybe some of you, if you're artists or something, you might have a much better spatial reasoning than I do, where you can like see what that's going to look like when it flips. But if I'm left just up to myself to try to flip that over the line y equals x, I'm probably not going to do it correctly, just like picturing it. I can do it whenever it's just over the x-axis or just over the y-axis, but to me it's difficult to do on that slanted line, just looking at it. So, since these are inverses, what it means is that every point that you have is going to have that inverse point on that inverse graph. So, if we look at this point right here, it is at negative 1, 2. So that means if we switch them, 2, negative 1 should be on our inverse function. Here we have the point 0, 3. So that means that 3, 0 should be here on our inverse function. Right? And so if I have this point right here, which is at 1, 6, that means over here 6, 1 is on my inverse function. So we're just switching the x and y's. Right here, this is the point -2, 3, which means we'll have 3, -2. And then at this point, I could probably figure out what it's going to look like from here. But this point is -3, 6, which means we'll have 6, -3. And so finally there, we can get that picture of that inverse. So if you just find the points of one graph and switch your x and y's, it's going to give you that reflected graph. To me, that's going to be especially necessary right here. Get my line y equals x drawn in here. Because this one, I can kind of picture it, but I'm going to have a little hard time getting those points exact. So any point that's on the line is going to remain on the line there. Right here, I've got the point, this is going by 2, so that would be 12, 10. So that means I would have 10, 12 right here. This point right here, I'm not sure it's perfect, but it's close. That is the point 16, 12. So that means I would have 12. Oh, I shouldn't write that there. It's in my way. I need 12, 16. That's going to run off my graph a little bit here, but this point right here would be 10, 12. Points on the line, stay on the line. I'm going to kind of guess at this one right here. That looks like it is probably -2, 5. Which means I would have 5, -2 right here. So, let me actually do these. So I've got, let me do these in different colors, my new ones. Here, so I've got these points right here are going to be my inverse points. So if I'm going to draw that in, I can kind of mirror what I see here. And it gives you some points of reference there for your graph. Okay, questions? All right. Okay, so let's go over how to find inverses algebraically. So this is just if we're just using the equation. So I probably am not going to put the graphs on the quiz tomorrow. Probably the only thing from inverses that's going to be on the quiz tomorrow is finding inverses. So this right here, this algebraic stuff where you're not going to need the calculator for it. So to find the inverse, the first thing that you're going to do is you're going to switch your x and your y. And in this case, that f of x, that acts like our y. In this case, it would be graphed on that y-axis. So I'm going to switch my x and my y. So I'm going to have x equals 2/3 y minus 5. So, and this makes sense, right? If we think about what we just did with those graphs, to get the inverse, we just switch the x and the y. So it makes sense that in the equation, you should be able to switch the x and the y here as well, right? So, then once you have switched your x and y's, you want to solve for the y. So where that y is at, you want to solve for that. So Grace, what would we do on this one to solve that equation for y? We got to get rid of the 2/3. We also got to get rid of the minus 5. Which one would we get rid of first? Yep. So to get rid of that 5, we just got to add the 5. Ooh, didn't need to do that. So I will get x plus 5 equals 2/3 y. Now we got to get rid of that 2/3. And so it's a fraction, which makes some people nervous, but it's just a 2/3. It's just a number. So if it was like 7y, you probably wouldn't have that much trouble with this, right? It's just 2/3 y. So you're going to divide both sides by 2/3. But that has a fraction inside of a fraction. Those are called complex fractions. In general, we don't ever really want to leave our answer with complex fractions. Your quiz tomorrow, it'll be multiple choice on this section, so I can guarantee you the answer choices won't have complex fractions left in the answers. So, whenever we divide fractions, what do? I usually say it about 1,000 times in every class. It doesn't matter if it's here or... We're going to flip the second and multiply. Dividing fractions, easy as pie. Flip the second and multiply, right? So, so the second is the bottom fraction. We're going to flip it and multiply. I'm going to write it out front, make it 3/2, and do x plus 5 because it does not matter what order I multiply in. I can put the 3/2 first, and that's just where we usually see that. And so here is our y all by itself. So we have solved this. You sometimes might see that 3/2 distributed. Sometimes it might be left. It just depends on what the answer choices look like, right? So I might leave it like this. I might distribute it. What I won't do is put both answer choices. So it might look like this. And the last thing you're going to do is you're going to change the y back to an F inverse. So F inverse of x would either equal 3/2 parentheses x plus 5, or if you see that distributed there, you would get 3/2 x plus 15 halves. So you could see either one of those. Put or right there. Do you guys remember doing this in Math 3? I believe it's Math 3 where you do inverses. Let's see. Some of you yes, some of you no. You guys last semester did it, right? Okay. Mr. Brown's crowd. Who had Mr. Brown? I keep forgetting. Okay. All right, so you guys have seen. Okay, good. All right. Okay. Okay, here is our next one. We got g of x equals x plus 5 to the third minus 7. And we're supposed to find g inverse of x. So we're going to just switch our x and y's. So we're going to have x equals y plus 5 cubed minus 7. And so we've got to get that y all by itself, which means we want to start furthest away from the y over here. So, Braden, what would we do first? Good. We'll add the 7. And what's going to come after that, Braden? We're going to take the cube root, because normally, like if it was a square, we do a square root. Right here, we got to do a cube root of both sides. If you do a square root, you have to put a plus or minus. If you do a cube root, you do not put a plus or minus, because you can take the cube root of a negative number. So odd roots don't need that plus or minus there. So and last step, Braden. We're going to subtract 5. Typically, you're going to probably see it written like this: negative 5 plus the cube root of x plus 7. It is okay to write it. I'm going to go ahead and put my f inverse here. It is also okay to, well, see, we might write it like this. Or it is also okay to write it like this: the cube root of x plus 7 minus 5. You usually don't see it written like this as much, just because if you draw your line out just a little too far, then that negative 5 is under the square root, which is not correct. So, but either is okay and could show up. Now, tomorrow you are not going to have Desmos, but I'm just going to show you this trick for when you do. This is also if you get some inverse questions on ACT, this is also a trick I want to show you. Desmos is practically cheating whenever it comes to some of this stuff. This is why I'm not letting you use Desmos tomorrow. Alright, so we've got, especially if it's a multiple choice, as it will be for most of these. If it is multiple choice, one thing you can do is you can say g of x equals, I should have used a g right there instead of an f. G of x equals x plus 5 to the third minus 7. And then I'm going to do y equals x for that line, and I could graph I'm just going to call this f of x. It doesn't like it if you try to do that inverse notation. Negative 5 plus x plus 7 to the 1/3. Are you guys okay with me typing it in like that? The cube root can become to the 1/3 power. Or you can go in the menu and get the root. But you can see these look like they're reflected, so that tells you yes, it's probably right. Here is what's really crazy though. Let's go back up to our original function. Like, I'm going to make that a y instead of a g of x. This is what we started with, right? So this is my answer. The green graph is the answer that I got. So we see it here. This one right here, what was our first step to find an inverse? What? Even before that, what did we do? We switched to x and y's, right? So, on Desmos, if you switch your x and y's, it graphs your inverse. So, you don't have to necessarily solve it. So, if you get a problem that's asking for an inverse, you could just take the question, switch to x and y's, don't even solve it, and then check your answer choices to see which one matches it, right, if it's multiple choice. So, I don't know if that'll show up on ACT, but if it does, that is a trick. You can't use Desmos on the quiz tomorrow because of that. Coach Wood loves some Desmos tricks.
No, I just told them to check the reflection.
Never told me. Yeah, I realized that the other day. Then
it still doesn't give you the answer.
It doesn't give you the answer.
For the inverse equation,
no, it doesn't give you the answer, and it's fine as long. But if it's multiple choice, it practically gives you the answer. Because you just type in all 4 answer choices and see which one matches it. But if it's not multiple choice, it just is good for checking.
I was taking the first test. She grabbed every single one of them on that
Yeah.
Thanks for your forward.
Yeah.
She's too smart.
So that's a trick that you can use to help you there if you are allowed to use. And I'll probably give you a couple inverses on the Desmos section of the test, or something, maybe some that are a little more complicated or something that you might be able to do this with, but you will not be able to use it tomorrow because I want you to be able to find inverses by hand also. And if you're just using Desmos tricks, it doesn't give you like the full picture of what I want you to do. Okay, well, I love these. These are a little more advanced. I want everybody right now to try this one on your own. I'm going to be impressed if you guys can get it. Now, you three that were just with Coach Wood, you guys may have done these. I'm not sure. Usually, my students can't do this yet. But maybe still switch X and Y. So, first step, of course, is going to be X equals 3Y plus 2 over, I'm sorry, that's 5. 5y plus 2 over 3x. I'm sorry, that's still y. There we go. Let me get it right here in a second. So, switching x and y's is the first thing that's got to happen. And unlike the other two we did, now you got 2 y's. So that makes it more difficult. Let's see if you guys can do this. Alright, so we've got 3xy equals 5y plus 2. And then I saw a lot of you trying to solve maybe like for this y right here. But the problem with that is that if you solve for this y, I'm gonna do it, but don't follow along. I'm gonna erase it back in a second. So like we could subtract the 2, 3xy minus 2 equals 5y, divide by 5. This is like seeming pretty good right here, right? Except when you get it solved for y, you still have a y over here on the other side. So that it's not completely solved for y because you still have a y on the other side. So that is not going to work for us in this case. So what we have to do is we got to get the y's together. But the big problem with that is it'd be easy if this was a 3y, right? We could just subtract the 5y and put those together. But it's a 3xy. So we can't subtract 5y from 3xy and like combine them because they're not like terms, right? So what I'm going to do is I'm going to move this 5y over to the other side. So I'll get 3xy minus 5y. I guess I am subtracting 5y, but I can't combine them. And here's where the magic happens. Both of these right here have y's. So I'm going to factor the y out. So y times 3x minus 5 will equal 2. And now I've got this y right here, a single y right there together now. And it's multiplied by what's in the parentheses. So I can divide both sides by what's in the parentheses. It will cancel right here. And we will get y equals 2 over 3x minus 5. And actually, let's replace that with our inverse. So that'll be f inverse of x. And just to make sure that it's right, we could always graph these here. So the original was y equals 5x plus 2 over 3x. That's what the original looks like. The inverse is y equals 2 over 3x minus 5. So they look pretty much like they're reflected. Sometimes they're a little hard to tell on these graphs because they get to be crazy graphs. We could always go do what we did on the other one, switch the x and the y. And you can see when we do that, we get the same graph as what we have here, so it is correct there. So the process for that, we multiplied, we moved everything with a y to one side and factored out the y, and then we could divide for that. So let's try another one that's similar. So for this one, we've got h of x equals x plus 2 over 9 minus x. We need to switch x and y, so we'll get x equals y plus 2 over 9 minus y. Okay. We cannot solve for anything that's in the denominator. You need parentheses when you do this. You're going to multiply by 9 minus y on the right-hand side, which is just going to cancel because this is in the numerator, this is in the denominator. And then we're going to multiply by 9 minus y over here on the left-hand side. So I'm going to have x times 9 minus y equals y plus 2. So our goal is going to be to get everything with a y on one side and everything that does not have a y on the other side. We can't really do that while we've got this x right here, so I'm going to distribute that x. So I'm going to get 9x minus xy equals y plus 2. And so we want all the y's to be together and everything that doesn't have a y to be on the other side. So I like moving everything to the left-hand side. You might prefer to you might move things to the right here. It doesn't really matter. I'm going to move my y over here. So I'm taking this y, I'm moving it over here. I'm taking this 9x. It doesn't have a y with it. I'm moving it over here. So I will get negative xy minus y equals 2 minus 9x. Make sure when you move something to the other side that you change its sign. Alright, now both of these have y's, so we can factor out that y. It's going to leave us negative x minus 1 and then that's y times the stuff in the parentheses, so we can divide by the stuff in the parentheses, and we'll get 2 minus 9x over negative x minus 1. Now, a couple years ago, I tried to give an assignment on this where you type the answers into Canvas. So that it was like, it was basically like a fill-in-the-blank problem, and I had a bunch of answer choices. I didn't have answer choices, but it was like going to read what you had and grade it. I realized really quickly that that was a terrible idea because there are so many ways that you can make your answer look. So this is one of them, right? This is the correct answer. But There's several other things that you may have done differently. You might have moved the y's to the right-hand side. You might have written this as negative 9x plus 2. There's so many things you can do differently that I realized I couldn't really do that for typing in. So when you see these, if they're multiple choice, your answer might not look like the answer choices that you see listed. Okay? So here are some other ways that this could look. Obviously, you can switch the order of stuff here. So it might look like this, y equals, it could be, maybe it might be negative 9x plus 2 over negative x minus 1. Like that's an option, right? Or even in the bottom, you might have negative 1 minus x. That's a possibility. So this would also be correct. You might multiply this one has a lot of negatives. Sometimes we don't really like to have negatives. So you could multiply the top by negative 1 as long as you also multiply the bottom by negative 1. Right? Because that's just multiplying by negative 1 over negative 1, which is 1, and it doesn't change anything. So if you did that, you would get y equals positive 9x minus 2 over x plus 1. I like that one better. I don't like all those negatives in the other one. So I might would do that if it were just me. So that would be correct. Obviously here you could switch the, you could switch the 1 and the x. You could switch the 2 and the 9 there and make it look like this. Negative 2 plus 9x over 1 plus x. That would be fine as well. So there, I realized where I had just typed in, maybe I typed in like 2 answers. I realized there were like so many different ways that students could type this in. I should not do that on Canvas where you have type-in answers anymore. But you may see these so I decided multiple choice is probably the only way to go on this. But your answer choice may not look like answer choices that you see there. So you need to, check and see. The other thing is if it's on a Desmos section, you can always graph your answer choices and see if they match what you got. Any questions? All right. Let's see. What have we got? 2 more things here. All right. I want you guys to try this next one on your own.